Flying in a climate-neutral way. How long do we have to wait?
The next few decades are, though, the important ones because we want to reach our climate goals by 2050.
More and more passengers are getting more conscious about their CO2 footprint.
We will need renewable hydrogen fuel.
There's no clear timeline today when it will happen.
Flying is considered the most climate-damaging form of travel. It accounts for 3.5% of global CO2 emissions. And this doesn't include the environmental impact of contrails, nitrogen oxides and soot.
The CO2 emissions only make up about 1/3 of the climate impact of aviation. The other 2/3 can actually be attributed to non-CO2 effects. And these are processes in the atmosphere and chemical reactions.
In 2023, there were 38 million flights worldwide, and air traffic keeps growing. Does that mean the situation is hopeless?
I guess it won't be easy to find an answer. I'm traveling through Germany to speak with scientists, industry experts, and critics.
The projections basically continue what we've seen in the last decades, that the aviation sector is very much connected to economic growth, and thus the aviation sector has seen continued growth in the last 3 decades and is projected to do so. So we not only need to decarbonize the current fuel demand and aviation sector, but also anything that comes on top in the next decades due to the growth.
So 50% of the people, the citizens worldwide, have never been on a plane. So how could you dare to tell them not to fly and see the world, as we did, we all did. And the future of aviation is absolutely closely 100% linked to sustainability.
Hydrogen is the great promise for environmentally friendly flying, since it emits only water vapor. In the summer of 2023, the first manned flight of an aircraft powered by liquid hydrogen took place. The plane was launched by German developer H2Fly in Maribor, Slovenia. There was a total of 4 test flights, one of which lasted over 3 hours.
The future of flying is being developed right here in the heart of Stuttgart, where H2Fly is located.
H2Fly was founded in 2015. The company develops propulsion systems of the future for aircraft.
We have the hydrogen as a fuel in a hydrogen storage system, and then we use that hydrogen direct in a fuel cell to convert the energy of the hydrogen into electric energy. That electric energy is used in an electric motor with a propeller or a fan to have the propulsion done.
There have already been several prototypes of hydrogen-powered manned aircraft. Take, for example, the so-called eVTOL aircraft from the US company Joby Aviation, now the parent company of H2Fly. Their goals are ambitious.
We have applications which go into a 40-seater, where we push into the commercial aviation to understand first what are the requirements, then to build the qualification base, to show the functionality, to demonstrate functionality in flight, and then to build a product. So we think that it is possible to fly in the 40-seater before the end of the decade.
Emission-free propulsion could be ready in a few years for smaller passenger aircraft. Well, but what about the big planes?
Major aircraft manufacturers like Airbus have various concepts for what the large aircraft of the future could look like. But they all have one thing in common: hydrogen electric propulsion. The original goal of developing larger hydrogen-powered passenger aircraft ready to hit the market by 2035 has been walked back for the time being, at least at Airbus.
The long-haul traffic, that's the traffic beyond 4,000 kilometers, it's only 5%, 6% of the flights worldwide, but it's more than 50% of the total emissions. And battery electric or hydrogen aircraft will not be able for the next 2 to 3 decades to transport 300 passengers in a reasonable way up to 6,000-8,000 kilometers wide. That's not going to happen. Technically, I'm pretty much convinced it will happen. It will be possible. But the question is whether there's a commercial viable model behind it.
The one thing is to develop the technology as we do and push forward. But on the other side, at the end of the decade, we will need tremendous amount of green hydrogen to propel those systems. So now it's a little bit of a chicken-egg problem we have to solve, because without the fuel, we will not have the technology in the market.
I think for a large-scale deployment of hydrogen, it will take another few decades.
There are many challenges. Hydrogen requires a lot of energy to be produced, and there are logistical issues.
The challenge for hydrogen is that it requires a completely new infrastructure and supply chain behind it, because at the moment everything is based on the supply of fossil kerosene, and so airplanes would need to be built in a different way, and the infrastructure at the airports need to change to accommodate for this new fuel.
Research into this infrastructure is being conducted in Hamburg. The Hydrogen Aviation Lab is located next to the Hamburg airport. It's operated by Lufthansa, Germany's largest airline. Many airlines have a strong interest in modernizing their fleets, if only for cost reasons.
Here in Hamburg, this retired A320 is used to research hydrogen-powered aviation.
Wir haben hier ein Reallabor aufgebaut, also einen Airbus A320 gekauft, den umgebaut zur Erprobung mit flüssigem Wasserstoff, zur Stromerzeugung. Ganz einfach, um Erfahrung aufzubauen, um zu lernen. Wir rechnen damit, dass so in den nächsten 10, 20 Jahren wir so die ersten mit Wasserstoff betriebenen Flugzeuge dann auch sehen werden.
The heart of the lab is located inside the fuselage. We are not allowed to film details. It's still top secret.
Was wir hier eigentlich machen, ist die ganze Prozesskette aufzubauen mit flüssigem Wasserstoff, von der Betankung, was wir draußen gesehen haben, des flüssigen Wasserstoff, der Lagerung, der Betankung ins Flugzeug hier rein und diesen flüssigen Wasserstoff dann so umzuformen in gasförmigen Wasserstoff wiederum, dass er in einer Brennstoffzelle zu Strom umgewandelt wird und dieser Strom wiederum dann an ein Bordsystem hier angeschlossen werden kann.
I do see a potential. First of all, I really admire all the innovations and the engineers working in this field. So I really think there is a big progress over the next years to come. But it's limited to short-haul traffic, and it's limited to only a couple of passengers on board of the plane. Because hydrogen is volume intense, so you need more space for hydrogen to be transported, and more space for the fuel, so to speak, less space for passengers. So you have smaller planes, 9, 10, 15 passengers on board. And this is not economically feasible, because at the end of the day, these passengers have to pay the high prices for such a small plane.
Everybody needs to learn hydrogen. We know hydrogen quite long as Hamburg Airport, but authorities need to learn, the whole infrastructure needs to learn, the aviation needs to learn, and most importantly, the passengers need to have confidence in hydrogen, because it's nonsense to have a new fuel and nobody wants to fly with it.
Climate-friendly and affordable flying with hydrogen, that will take some time. Is there a sustainable path for air travel that can be taken now, or at least faster?
And what about aircraft CO2 emissions? Can we expect rapid improvements?
The green transition is going to work, first of all manufacturers working on less fuel efficient and by that less CO2 emitting aircraft. And airlines are working on the fleet modernization because less fuel burn is in their major interest. So at the same moment, they have also less CO2 emissions up in the air.
Right now, the most environmentally friendly aircraft in operation is the Airbus A350. Thanks to modern engines and lighter construction, it consumes only 2.5 liters of kerosene per passenger per 100 kilometers. This means it emits 25% less CO2 than its predecessors. Lower consumption is one aspect, and then there is the so-called SAF, Sustainable Aviation Fuel. SAF is a non-conventional fuel, sometimes produced from organic waste or renewable raw materials.
Inherent is a chance, an opportunity that the greenhouse gas emissions of sustainable aviation fuel is 80% less than conventional fuel. But also the non-CO2 emission, which can be seen as contrails up in the sky. Sustainable aviation fuel propelled aircraft produce less contrails. So there is a massive, massive chance that sustainable aviation fuel makes a huge impact. It's a drop-in fuel. You can use it. You don't have to set up hydrogen infrastructure at airports, which doesn't exist.
What do you think of SAF, sustainable aviation fuel? Is it a solution or an illusion?
Sustainable aviation fuels can be green if we ensure that all the inputs needed for the production of it are sustainable, for example, using renewable electricity or using a sustainable CO2 source, for example, capturing it from air or using biogenic sources.
Hope for the future. Currently, Airbus aircraft can be fueled with up to 50% SAF. This share is to be increased to 100% by 2030. But there is a major catch: the large amount of energy required to produce synthetic fuel.
It is a huge electricity demand. For example, to cover the fuel demand of the aviation sector in Germany, which is, I think, about 385,000 terajoule in 2020. To cover this completely with these synthetic fuels, it would require over 35,000 onshore wind turbines, which is a lot. And I think that relates to about 21 nuclear power plants.
It's a fact. Zero-emission aviation is far off. Sustainability takes many small steps, and one of them is the Net Zero 2035 project.
The issue of CO2 reduction doesn't just affect aircraft. Flying also involves airports. Hamburg Airport is aware of the problem. With the Net Zero 2035 project, the airport has a clear goal.
The Net Zero project, what is it actually? What's the idea behind all that?
The basic idea is to bring our airport operations to net zero fossil-free operations. Means that everything that emits CO2, fossil CO2, is going to be reduced to zero, so that we basically have net zero CO2 emissions.
The passenger stairways are solar powered. All vehicles are being converted to electric and hydrogen power, while climate management systems in all buildings are being modernized. They're also building a wind farm to supply all of the airport's energy.
Our base year is 2009. Since then, we reduced something like 80 to 85% of our CO2 emissions already.
Does it pay off for the airport?
Does it pay off for the climate not to do it?
Flying in the future will likely be greener, but probably more expensive. So what's your take? Will you fly like nothing's changed, cut back, or quit flying for good? Feel free to leave a comment.